404 Reservoir Not Found is a project designed to act as an AI assistant for history matching, one of the most delicate and time-consuming phases for a reservoir engineer. From the landing page, users can generate the required input files for IX, one of the most widely used reservoir simulators, simply by importing the folder containing the main model input files. The simulation is then run externally, and once completed, the results folder can be selected back in the tool. The system automatically parses the outputs, reads all the key data needed for the analysis, and once the case is activated, users can open the dashboard and access the core of the application. The dashboard provides a quick overview of the model history match quality through KPIs and an interactive well map. Below, a deterministic analysis suggests possible improvement actions, while the chat box enables collaborative AI agents to run deeper analyses, generate plots or maps, and show the full workflow trace. By clicking on a well, for example HW28, users can review detailed KPIs, notes, and an initial deterministic interpretation. Based on this diagnosis, the tool can generate input files to update key model properties in the next simulation run. Below, the chat box represents the core of the system. For example, we can ask, provide an integrated root cause diagnosis of the water mismatch for HW28, and the agents will collaborate to perform the analysis. Here, the system provides a detailed analysis of the critical variables, the most likely root cause, and the next checks to perform. On the right, a summary table highlights the objective evidence supporting the conclusion, while the agent trace below shows how the different agents cooperated to generate the final answer. Let's take a quick look at what happens behind this question. For HW28, the system plans the task, calls multiple specialist agents, and gathers water, profile, and diagnostic evidence. A critic agent then ranks the hypotheses, identifying relative permeability and water mobility as the leading cause, with connectivity as a secondary check. Now, let's ask the system to display the porosity map. As shown, an interactive heat map is generated, allowing users to explore the grid, move the mouse across the cells, and read the corresponding porosity values directly. Now, let's ask a more complex question. Identify the wells with the weakest pressure match and explain what they have in common. The system provides a focused analysis of the wells with poor pressure matching, highlighting recurring variables that may explain the mismatch. On the right, a pressure distribution plot helps visualize what is happening across the reservoir. Overall, this tool enables engineers to use AI agents to investigate multiple aspects of the reservoir model, obtain more robust interpretations, and generate practical actions that can be tested directly in the next simulation run.